We are keeping the ball rolling, made up of myself, Wyatt Klein,
Brad Haig,
and Daniel Ayala. Welcome to our presentation for our proposed Battle Frog Rube Goldberg machine.
Today we will talk about the opportunities presented to us and how we took advantage of those in the concept generation phase of our Rube Goldberg machine. We will also talk about how we planned each step of our process in developing and producing the machine, as well as the time frame between each step in the management process.
In addition, we will expand on how we determine the customer needs and how these translated into our team's target specifications for the machine.
Lastly, we will discuss the economics of our proposed machine, including benchmarking, revenue cost, and profit we expect to see.
Our mission is to produce a simple Rube Goldberg machine that will teach simple physics concepts to young children, preferably late middle school children, and hopefully kickstart their interest in physics early on in their lives. We want our design to entertain and grab the attention of these kids, be easy to assemble and store, be safe for all ages, and lastly, be very affordable for the average family or school system. We will aim to market our product within the Blacksburg and Christiansburg area in which we can manufacture our Rube Goldberg machines in bulk and sell them to these school systems. The team debated on a fully modular product in which small sections of the machine will be pre-built, a bare bones product in which the customer will have to do most of the assembly, and a combination of the two. After much consideration and analysis of the product's expected growth in the future, we determined that a combination of the two will be the most appropriate, as you can observe in our expected S-curves.
We established the shown Gantt chart using Microsoft Office in order to determine the critical tasks and lay out a project schedule in order to establish guidelines and timescales for each task as well as relationships between tasks. This Gantt chart helps ensure that the project will be completed in the allotted time and helped us determine tasks that could delay the team and show our current status in our development of the project. As shown, this is our completed Gantt chart. You can see that we began with the identification of customer needs, and after gathering the appropriate customer needs, we used these to establish our target specifications. We then concluded further research to move on to the concept generation phase. Upon completion of this, we would test our concept and the corresponding architecture, which can be completed simultaneously. Likewise, the industrial design and the design for manufacture will follow, also to be completed at the same time. Throughout the duration of these parallel tasks, the economic analysis will be conducted. Lastly, we will go through a prototyping phase where multiple iterations of our design will be tested and validated. The project will be concluded December 1st, and the total duration of the project will be under 3 months.
The customer profile was created based on the predicted customer needs for the Rube Goldberg machine. We decided to choose a school as it provides a large amount of students to teach and can result in a large amount of sales throughout many school systems. This product will appeal to this type of customer because it will gain the attention of students with the hopes of provoking an early interest in physical concepts through interaction and ultimately improve the school's proficiency ratings. The use case was created primarily based on the predicted use of the Rube Goldberg machine by the ideal customer, a school. This provides a basic demonstration of the product's usage, which was selected to be a science fair display within the school. This is done by first assembling the machine and then placing it on display where students can watch the machine function and participate in the interactive portions as well. Ideally, the students will leave more interested in physics than they may have been previously and having learned about a few basic physical concepts. A number of customers were selected to be interviewed based on the possibility of using the Rube Goldberg machine. Most of these consisted of schools, where the staff as a whole was interviewed, and individual teachers, but also included a parent. Customer statements were gathered, and non-repetitive statements were evaluated in order to determine the corresponding customer needs. Then, the customer needs were voted on by the team in order to determine the importance of each to help create the product specifications. As you can see, the most common customer statements are presented and the corresponding customer needs have been generated. The most outstanding customer needs we have developed are product affordability, product ease of construction, product safety, educational value of the machine, the ability to store the product, and lastly, the aesthetics of the product.
Based on the discovered customer needs, the team decided that the most appropriate target specifications would be weight, volume, educational, modular, consistency, and durability. Weight will be measured in pounds, volume will be measured in cubic feet, level of education will be measured in appropriate grade level, modular will be measured in parts, consistency will be measured in percent success, and durability will be measured in lifetime runs. Based on our customer needs and their correlation to our target specifications, keeping the machine's volume down was the most important aspect of our design according to the QFD, whereas the most difficult specifications to meet will be our target consistency and durability. Based on the result of our team's QFD, volume will have the most technical priority for our design. As you can see, we directly related our target specifications with the customer needs we have based off of the customer statements. Each specification is given a value of correspondence with each given customer need it applies to. These values were then used to determine each specification's technical importance, difficulty, and priority, as you can see right here.
Using the QFD as well as specifications set by the manager, the team determined the variable cost and fixed cost. We decided on the price after researching the cost of materials and taking into consideration competing Rube Goldberg machines such as the one shown. After much consideration, the team agreed on $30 as a fair price for the machine. The total revenue was calculated by multiplying the price of the machine by the number of items sold. The total cost was calculated by adding the fixed cost by the variable cost. The variable cost was calculated by multiplying the number of hours the workers worked multiplied by their wage. Lastly, the profit was calculated by subtracting the total revenue by the total cost. As you can see here, our product is predicted to break even after 3,200 machines are sold in order to ensure a positive profit.
In conclusion, our team wanted to create a fun, educational Rube Goldberg machine in order to teach middle school students the joys of physics.
The team organized our production and manufacturing with the developed Gantt chart. Interviews were conducted in order to establish the customer needs and specifications. The team researched multiple machines in order to see what else was on the market. Throughout the generation process, the team evaluated the price, revenue cost, and variable cost.
Presently, we are in the concept generation portion of our design and hope to move into concept testing within the next 2 weeks. We would like to thank everybody for their time, and if there are any questions or concerns, feel free to contact any one of us.